Hello, my name is Holly, and as we close out this semester, I wanted to focus my presentation on taking a deeper dive into the pheromone detection system, specifically its function in domesticated cats and dogs. Have you ever seen a cat look at you like this? Or taken a walk with a dog who had to stop every dozen yards to mark their territory? Dropped a snack on the ground only to find it swarmed by ants hours later? All these animals are using pheromones to communicate with each other, so it follows that they have a sensory system capable of detecting and interpreting these types of chemical signals. While there is some evidence to suggest humans can and do utilize some similar form of chemical signaling, which was touched on in the textbook, we don't actually possess the ability to sense or perceive pheromones. To recap from the textbook, pheromone sensory system is a subset of the olfactory system. We can think of the olfactory system as consisting of two parts: the main olfactory bulb, which detects odors, and the accessory olfactory bulb, which detects pheromones. Despite the fact that the accessory bulbs rest atop the main olfactory bulbs, these sensory systems are separate and do not share any synaptic pathways. As a brief refresher, odors are small molecules that produce the perception of scent, while pheromones are molecules that are typically too large to be detected by our main olfactory system. As far as we can tell, pheromones don't really smell like anything. Their purpose is to trigger a physiological or behavioral response as a form of communication. Another difference between these two types of olfaction is that while the perception of odors is spontaneous and passive, as with every breath, odors pass over the olfactory mucosa, the detection of pheromones must be actively triggered. In mammals, this occurs during a behavior known as the Flehmen response. The Flehmen response looks like this. Some people call it a stink face or a scrungy face. In cats, it involves raising the upper lip with the mouth partially open, often accompanied by movements of the tongue. In dogs, it may present as panting, raising the upper lip or scrunching the nose, or general tongue movements. Flehmen behaviors serve the purpose of carrying pheromones to the receptors located in a structure nested above the roof of the mouth, called the mammaronasal organ, or Jacobson's organ, which communicates with the accessory olfactory bulbs. For the purposes of this presentation, I'll be referring to it by the acronym VNO. During Flehmen, facial muscle contractions open ducts in the VNO, while vasoconstriction of the organ's walls expand it, opening up the lumen or empty space inside. This fall in pressure creates a suction that carries pheromones in, and once they've been picked up by the receptors, the VNO is washed out as blood pressure increases back to baseline and the organ constricts again. The precise mechanism that occurs after this point to carry the pheromone signal to the brain is not yet fully understood, but evidence suggests that part of this information pathway is the responsibility of the mammaronasal nerve, which connects the accessory olfactory bulb to the amygdala through the limbic system. Of note, there appears to be no communication with the neocortex, even through the thalamus, which is another way that pheromone sensation differs from odor sensation. The pheromone system was initially thought to only exist in invertebrates, but in the order Carnivora, we can find an abundant variety of glands that secrete chemical signals. In cats and dogs, there are 6 major sources of pheromone secretion that we know of: the facial area, the pedal complex, so pads of the feet and between the toes, perianal complex, so anal sacs, the circumanal area, the base of the tail, the genital area, the mammary complex, which is the sulcus between 2 mammary chains, and the lumens of the anal duct and urinary tract. So these secrete pheromones into the urine and feces. There are certain behaviors that our pets do that not only help them release and distribute these pheromones, But by doing these behaviors, they're advertising for others that they're giving a pheromonal signal, and the receiver should engage in the phlegm response. Both the pheromone and the behavior are forms of communication. Cats rub and nuzzle their faces against objects or other animals in order to wipe the secretions of their facial glands as a way of claiming that thing. The pheromone that's released during this rubbing, called an allomarking pheromone, decreases aggressive behavior and increases sociability between the cat and the marked individual. This way of marking helps organize the cat's environment into known and unknown objects. So if a cat nuzzles up against you, it's a good sign that they like you and consider you part of their world. Another way of marking territory in both cats and dogs is scratching and digging. Both these behaviors leave physical marks on the environment that, when seen by another animal, encourages that animal to then start searching for pheromones. Dogs have these complex rituals of behavior surrounding sniffing each other's perianal glands to detect alarm pheromones or signals of fear and aggression. Veterinary behavioralists have even found that dogs with bacterial infections in the GI tract are more prone to being treated with aggression by other dogs, potentially because these infections change the chemical composition surrounding these pheromone glands. As we learned in the textbook, pheromones can be broadly classified as either primers or releasers. Primers are slow-acting, meant to induce a physiologic response in the receiver, while releasers are meant to be instantaneous behavioral triggers. This pheromone class is the focus of a very interesting approach to veterinary medicine that I wanted to share with you, that being synthetic pheromones used in behavioral therapy. On screen, you'll find a list of known feline pheromones and their associated behaviors. Over the last few decades, researchers have been able to synthesize analogs for some of these secretions that can actually work in much the same way as the pheromone in domesticated cats. The first pheromone analog to be synthesized for carnivores is the analog for F3. You can even find and purchase this at many pet supply stores. It's called Feliway. Synthetic Feliway has been shown to markedly decrease signs of anxiety in household cats, as shown here. Cats introduced to a new environment were more likely to eat and return when it had been sprayed with Feliway than without. They also were less likely to have inappropriate urination in a new environment if there was Feliway there. Cats transported in vehicles were calmer and again less likely to inappropriately urinate, defecate, or vomit if they had been exposed to Feliway prior to traveling. Another synthetic analog you may have heard of is Felifriend, a mimic of the F4 pheromone, which is the allomarking signal introduced earlier. Again, there's evidence that this pheromone analog can drastically reduce aggression and anxiety in cats. During veterinary visits, cats are less combative and more likely to be the ones to initiate friendly contact if the vet had Felifriend on their skin. So while these synthetic pheromones show huge promise in the field of behavioral therapy, using pheromones in isolation doesn't quite capture the full picture of pheromonal communication. Typically, pheromone release and detection correspond with behavioral cues or environmental changes that we discussed earlier, that let the receiver of the signal know when to open their VNO. Pheromone detection isn't like auditory detection, touch, or even typical olfaction. It has to be activated in order for an organism to use this sense. It's a very interesting sense that allows for complex and nuanced intraspecies communication. Pheromones influence animals' physiology, behavior, and social structure in ways that we are only beginning to understand. But by gaining a better understanding of this sixth sense, we'll be able to better treat and improve the well-being of not just our pets, but all animals that we interact with. Here are the literary sources I used for this presentation. The graphics used were taken directly from these materials or from the textbook, except for the videos, which were just taken from various internet sources. Thank you for listening, and enjoy your summer.